but then the power would go off in that case of a dropout relay. Well, the things that are most susceptible to over voltages are capacitors. They explode, right? If they are single phase capacitors, your MOSFETs in your electronic devices will fail, and your power supplies, as we've discussed in the PlayStations and even phone chargers. I've watched the neutral be disconnected, and I've seen a phone charger physically go smoke and stuff. So yeah, it for a fact happens, and yeah, it's not very safe. And the neutral comes loose on residential supplies way more often than people think. So technically, the causes of over voltage switching loads could cause an increase in the voltage. Another thing would be disconnecting your neutral at the supply kiosk of, say, in a TNCS system. You could disconnect your neutral, all your phase voltages. Your phase voltage between live and neutral floats up to like 400 volts. I've seen it, and it pops things. And then the third one is if you do have an inverter system with a terrible loop resistance back to the transformer, when it tries to export, it'll obviously have to, because that's the way. I don't know if anyone, I don't know if you know this, but you do have to elevate voltage to push current in the opposite direction, right? So your inverter system will essentially have to elevate its voltage to export power, or not fry them, but just leave them with the highest tolerable over voltage that it can work with. Some of these systems will literally probably kick it off. They'll find out, oh, I'm overvolting, and they'll go into error. Obviously, there is actually another one. It's the utility transformers. Tappings can be set too high, and then when the current of the feeder drops, like in idling loads, you find excessively high voltages by like the first home and stuff. This is very common, and this is very common in like poor voltage regulation.